Welcome students. So now in the process of learning about the time value of money and how to calculate the time value of money and what is the purpose of time value of money, we were talking about this present value of uneven series in the last class, in the previous class, and there we saw that when you get the uneven cash flows over the different durations, and this happens normally in the new ventures or any project, any investment venture when you go in for, when you make investment into the ventures and you become entrepreneur. So cash flows occur something like this, and they remain normally uneven because you cannot expect say a cash flow in the even amount or the even series. Every year the cash flow cannot be same because largely cash flow will depend upon the profitability of the firm, and profits cannot remain same. So it means when you are going to have the uneven amount of the cash flows, so that uneven amount of the cash flows we are going to find out the present value overall, maybe you call it as the cash flow stream, but that overall cash flow stream's present value will depend upon when you will discount each years of the cash flows against the given number of years and the discount rate. And finally, when you sum it up, so you will get the present value of the entire cash flow stream. So in this case, we see here that we are given a formula here. So if you see the model here, this model is something very a simple model. You call it as the summation of all the cash flows. AT means cash flows over the different years or the different durations, and divided by 1 plus R. So R is basically the discount factor and T is the time, number of years. So in this case, for example, this is 1 plus R power 1, this is power 2 and goes up to power n, and this A is basically the cash flows. So cash flow A1 in the first year, for example, in this case you are given 1000. Cash flow in the second year A2, it is 2000, and so on up to the AN number of years. For example, this is a A8, that is the 8th years of the cash flow, which is 5000 Indian rupees. And depending upon the discount factor, so R we have assumed here is, for example, 12%, and N here is the number of years. So we are finding it in the table, the present value table, and for this in the PVIF table we'll find out that what would be the, say, discount factor for at the rate of 12% discount rate, and for n number of years, maybe the one against that 12% and 1 year, first year, you will find this factor, that is 0.893. So when you multiply this with this, you will find out this one, and this is going to be the value of 1000 rupees earned 1 year after from now, from the current period, would be 893 rupees at the discount rate of 12%, and this discount rate of 12% is basically the weighted average cost of capital, that this much of the return you expect from any investment which you want to make, that your investment deserves this much of the investment return on the investment, that is 12% return you deserve, your investment deserves. So that becomes the weighted average cost of capital for us, 12%, and we are discounting it at 12% for the different number of years. And when you are summing up the discounted cash flows, this comes up here as 13,376. So what was the total amount here? If you total it up, this will come up as something called as the 24,000 rupees. So 24,000 rupees of the say cash flow over the period of 8 years, having the uneven cash flows over the years, and say multiplied by the discount factor at the 12% and given number of years. So that 24,000 rupees of the absolute value has come down to 13,376 as far as the present value of the entire cash flow stream is concerned after discounting the cash flows. So it means we want to know that we are making investment today, and that maybe the cash flow can be any amount. It can be 1000, 5000, 1 lakh, 5 lakh, 1 crore, 5 crore or 10 crores or 20 crore or 50 crore or 100 crores. And out of that investment, so it means when you are making the investment in the current year, the value of that investment is same, that is the 1000, 5000, 1 lakh, 5 lakh, 1 crore, 5 crore or 100 crores, but the cash flow occurring over the different periods of time. For example, first cash flow of 1000 is coming to us after 1 year. So how much is that in the present day, or what is the value of that in the current time? And that 1000 when we will receive after 1 year, as per the today's scenario, means after 1 year when we are receiving this 1000 rupees, that will be equal to the 893 rupees of today, because it is coming after a span of 1 year. Similarly, the 2000 being received after 2 years, right? 2,000 rupees of the cash flow being received after 2 years, if you are discounting it against 12% and 2 number of years, so the value of that 2,000 would be equal to the 1594 rupees of today, right? So it means we have to discount it, we have to calculate the say total summed up value of the entire cash flow stream, the present value of the cash flow stream, and then we have to find out that given value of the cash flow, absolute value of the cash flow stream, how much it comes up after discounting it against the given discount factor and number of years. So very simply, we can use this model, this formula, and we can calculate the present value of the uneven series. And in the practical sense, always the cash flows coming out of any project, any investment venture, any enterprise would be uneven in the value, because over the number of years the profit will not remain the same, and similarly the other sources of the cash will also not remain the same, they will change. So as the entire input figures are going to change, naturally the cash flow as an output is also going to change. So always there would be uneven series, and practically if you want to find out the value of that total cash flow which we are receiving over a period of 8 years, so absolute value was 24,000, but the discounted value is almost half of that. So it means it can tell us that when you want to make a comparison between the outflow and the inflow of the cash, so you have to make a comparison not with this figure of 24,000, but with this figure of the 13,376 of the total outflow. So how much is outflow? For example, in this case, the outflow is total investment we have made here is, say for example, 15,000 rupees, right? And your inflow is coming up here as a discounted value of the inflow is 376. So you will call it as this is in minus. The present value is going to be in minus. So when you talk about the NPV of the project, net present value of the project, when you are going to calculate, it is going to be 13,376 minus 15,000, means you cannot say minus, it is equal to. So this is cash outflow, right? This is cash outflow and this is going to be cash inflow. So cash outflow was 15,000 and cash inflow is 13,376. So when you subtract 13,000 from 13,376, 15,000 rupees of cash outflow, the net present value would be something in negative. And we don't want to go for this kind of the investments. But for example, if it is 10,000, it's not 15,000. So in that case, this is going to be positive. This NPV is going to be positive. So it means we invested 10,000 rupees and after over a period of 8 years, summed up value of the entire discounted value of the entire cash flow stream is 13,376. So you call it as your NPV is how much? In this case, NPV is going to be 3,376, which is positive. So depending upon the cash outflow, what is the discounted value of the entire stream of the cash inflows, we'll make a comparison with that, we'll calculate the NPV, and if the net present value, it means if the NPV is positive, that's a very good state, and the minimum decision making criteria is that the NPV should be 0. If it is minus, we will not go for making investment. If it is plus, we will make investment, and even if it is 0, we can make investment, we can go for the venture and we can make investment in that enterprise and we can set up our own business. So this is very important analysis. This technique of time value calculation is very important, and with the help of this time value technique, we normally calculate the net present value of the projects and we try to find out how much the investment we are going to make, what is the value of the cash outflow, and how much is the inflow going to be available over the foreseeable life of the project, and what is the difference between these two. So decision criteria is that if the difference is 0 minimum, we can still go for the project, but if it is minus, we will reject it, and if it is positive surplus, we will certainly go for making the investment. So this we discussed in the previous class also. I thought of repeating it because I hurriedly discussed in the previous class, so I thought of re-emphasizing on this technique because this technique is very important, and in the subsequent discussion while talking about the investment evaluation criteria, risk analysis and other things, cash flow analysis, we will talk about this important technique. So I thought of repeating it in this class and just re-emphasizing upon that calculating the present value of an uneven series is the most important component of the time value of money. We can use it for the evaluation of the new investment proposals. Now the next thing is the future value of an annuity. Future value of an annuity. So while calculating the future value of an annuity, first of all we have to understand what is the annuity or what we define the annuity as. So it is clearly defined here. An annuity is a series of the periodic cash flows, whether it's a payments or receipts of the equal amount. Annuity means equal amount. And periodically we are going to have that cash flow. It's a series, periodical series of the cash flows. Maybe you are making the payment to somebody, that is also annuity. If you are receiving something from somebody, that is also annuity. And basically that is an equal amount, and we are going to calculate the future value of that annuity. So normally this kind of the analysis is important for us, that when we are making the investment into any venture, here for example you give this money, you are not making this investment into any venture, but you are giving this money to the bank, and you are having a kind of a recurring deposit account, right? So there we can use this kind of the analysis. In the projects also, you treat the project also a recurring deposit kind of a account in the bank. And for example, if you are going to make investment in any venture, and for a period of next 3-4 years or 5 years, you have to make the investment in that venture, and after that you want to find out what would be the future value of that investment which you are making into that venture at the end of any particular year up to 5 years. So finally, if you want to know the future value of that annuity, and when that investment you are making into that venture, that is going to be the same amount, right? Periodically you are going to invest the same amount, equal amount, and in this case, for example, we are assuming it as 1000. We are depositing 1000 every year, but at the end of the year, not at the beginning of the year. So when we are going to deposit this 1000 at the end of any year, so how much it is going to be? Sum total of this means when you talk about the future value of this annuity, how much it is going to be. So in this case, when you deposited the first 1000 rupees, or you invested into any venture at the end of the first year, not in the beginning of the first year, it's a period of time analysis, not point of time analysis. So at the end of the first year when you invested 1000 rupees, so you are compounding it for how many years? You are compounding it for the 4 years. Year 2, year 3, year 4 and year 5. So compounded value of this 1000 over a period of the 4 years, because first year will not be counted. First year is at the end of the first year you are making investment. So you have total 4 years, and after 4 years this 1000 becomes 1464. Second 1000 you give at the end of the second year. So you have the compounding period of 3 years, and this 1000 becomes 1331. And third 1000 you give at the end of the third year. So you have the compounding period of only 3 years, and this amount of 1000 becomes 1210. And fourth year, when you give at the end of the fourth year, when you invest this 1000 at the end of the fourth year, it becomes 1100, and that any amount invested at the end of the fifth year. And when that amount is going to, this account is going to mature, so this 1000 would be equal to 1000 only. So total summed up value of all this amount, how much you are going to invest here? You are going to invest here is something like that 5000 rupees over a period of 5 years. And after that it's becoming, if you calculate the future value of this amount becomes 6105. It means future value of an annuity, whether that investment you are making in a bank, you are making in a project, in any kind of the venture or any other kind of the investment avenue, how that investment is going to grow, means this is the magic of compounding, that you are not drawing the interest on the periodical intervals, you are reinvesting the interest back. So compounded value of 1000 in the first year, at the end of that on the period of fifth year after 5 years, it becomes 1464, and similarly the other amount grows, and finally the sum total of this is becoming 6105. And finally this is the magic of, you call it as the compounding. And any amount when you deposit in any account, if you do not withdraw the interest on the periodical intervals, if you allow the interest to be reinvested back, so in that case the final amount comes out to be certainly more than the deposited amount. And in this case we are depositing 5000, we are getting back 6105, and finally the future value of an annuity is more than the total invested amount. So here we are calculating year by year and trying to understand that what is the interest factor and what is this value going to be. But practically you can use this model. It's a very simplified model, and with the help of this model you can easily calculate the future value of an annuity, which is A. A is basically the cash flow, outflow or inflow, and R is the discount factor, N is the number of years and minus 1 divided by the R, again the discount factor. So to understand this technique very clearly, we have this concept, and by using this concept as well as the present value concept also, both the concepts, present value and future value concepts, both the concepts, after using these concepts or on using these concepts, we can have number of applications of the time value of money, and these applications of the time value of money are going to help us in a big way. So, for example, this is the application of the future value of an annuity, right. This is the application of the future value of an annuity which we saw here. Here we have deposited 1000 rupees at the end of each year, which has become after 5 years 6105 after depositing 5000 rupees. So, if you want to see how you can apply this, not even this technique, even the other techniques also, if you want to apply the other techniques also, so those techniques would be giving you the proper understanding of the applications of the time value of money, and finally you are going to say know about it, that how the different applications of the time value of money or the applications of the techniques of the time value of money can be taken care of. So, in this case, first application is for example, what lies in store for you. So, how would you understand this? It is given to you here very clearly that suppose you have decided to deposit how much, rupees 30,000 per year in your public provident fund. So, here we are using the example as a public provident fund account, PPF fund account, but in the real sense you can say there is some project also or some venture also, right. You can make investment in this venture also or on the project also, or anywhere you can set up your own business, your own project or your own venture. So, here we are taking this assumption that we are making this investment in the PPF for a period of how many? 30 years. What will be the accumulated amount in your public provident fund? What would be the accumulated amount in your public provident fund at the end of 30 years if the interest rate given on this amount is 11%? So, this is the same model we are using as we use in case of the future value of an annuity. This model was A into 1 plus R power n minus 1 divided by R. Same model we are going to use to find the answer of this particular question, what lies in store for you. So, here we are taking A. A is basically the cash outflow which we are investing into the PPF. R is basically the discount rate or the interest rate you can say. N is the 30 number of years. Again this R 0.11 or 11% is we are taking in the denominator and minus 1. By applying this formula, you easily get the answer to your question what lies in store for you when you are depositing 30,000 rupees per year in your PPF account, and after 30 years how much is going to be the value. So, this amount which you are investing finally is going to be something like that, 59,70,600. So, it means it is going to be close to 6 million Indian rupees. It is going to be close to 6 million, 60 lakhs or 6 millions of Indian rupees, close to approximately 6 millions of Indian rupee. So, this amount is going to be. So, how much you deposited in this account, right, over a period of when you are depositing 30,000 in a year, how much you deposited and finally how much this amount has become. So, it means you can understand that your total amount you deposited was something for a period of 30 years. When you are depositing this amount is how much and how much this amount becomes. So, the difference between the given amount and the finally means the amount which you are going to receive after a period of 30 years at the rate of 11 years is basically, again you call it as the magic of compounding. You deposited 30,000 per year and after 30 years is going to be how much, right. You can simply understand that this amount is going to be this is going to be close to 6 million or 60 lakh rupees. So, how much you deposited? You deposited here, say for example here when you talk about 30,000, right, and how much is the period? It is going to be 30 years of the period. So, you are going to give how many? You have deposited 9 lakh rupees because 30,000 you are giving every year and you are giving it for the, so it is 30,000 into 30 years. So, this amount is going to be 9 lakh rupees. You are depositing 9 lakh rupees and this 9 lakh rupees is becoming close to 60 lakh rupees after a period of 30 years. It is close to the 6 million Indian rupees. So, you can understand at what rate, how fastly it has grown up, how much it has become after a period of 30 years when you are depositing this money. So you can take it as a venture also. For example, in any venture, in any investment avenue, if you are able to find out that I am going to invest every year, my investment in that venture is going to be 30,000 every year, and I will be giving this money for 30 years. Maybe you call it as not directly you are into the business, you are going to entering into the business through stock exchange. You want to become the owner of a business or any company through stock exchange. So every year you want to invest 30,000 rupees, and for example, on an average, the annual rate of return from that investment works out to be 11%. And you do not take this money back, and it acts like a compounding sum. Means, for example, stock market gives you the positive returns, there is no ups and downs, there is no serious crash of the stock market, no recessions are there, nothing like that. So your investment of this 9 lakh rupees given over a period of the 30 years will become close to 60 lakh rupees, or maybe the 6 million rupees. And this will be normally, if we assume, normally in the stock market the compounding process doesn't work, but we assume that everything remains positive, there is no downfall, everything grows up, and we get on an average the return every year, the return of 11%, and whatever that 11% we are again reinvesting back. Maybe that 11% you call it as both the capital gain as well as the your dividend, and you are reinvesting back the same amount into the same stock or same market or maybe same investment avenue, or maybe in the bank itself. For example, you have some PPF account, you have some RD account, recurring deposit account with the bank, and you are not taking the interest back on the periodical intervals. So this sum will become maybe from 9 lakh rupees of the total investment you are making, your outflow of 9 lakh rupees over a period of 30 years will become close to 6 millions or 60 lakh rupees. So this is a very important application of the time value of money, which is going to help us to understand that your growth of your funds due to the magic of compounding is very fast, provided your investment is constant and the interest rate is also a decent interest rate, right? For example, if the interest rate is say half of this, 5.5%, so you can understand this investment will not be even half of this amount, it can be even 30 lakhs or even less than that, right? So normally it becomes upon that how much return is available. So when I say that people look for the different avenues of investment, why they look for the different avenues of investment, that they are not satisfied with the rate of return being given by the safest mode of investment. For example, when you go to the bank and you want to give your money to the bank, how much money means the return the bank would give it to you? Maximum 6% or 7% they can give it to you, right? But they will not allow you to withdraw any amount or anything. You have to keep the money with them, and you have to reinvest the interest also automatically. You are not getting any interest back or any principal back. Same is the case here also in the PPF as well, but still the return will not be 11% in the bank as it is here in the PPF account or in any other investment avenue. For example, in this we are assuming 11%. So if the rate of return is 5.5% or 6%, you can understand at what rate your money will grow. And for example, if the inflation is also 6%, it means there is no growth in the value of your money, your investment, but yes, you have been able to preserve the value of your money. So it means every year of the reduction of 6% in the value of your money is being made good by the interest you are earning on that. So at least you have been able to preserve the value of the money, and even 30 years after 30 years also you can buy the same amount of the goods and services as you are going to buy today. So there is no increase in the value of money, but there is no decline also, there is no decrease in the value of money also. So when people go for higher rate of returns, looking the avenues which are giving them higher rate of return, it means they want to look for the bond market, they look for the stock market, or they look for the investment opportunities in the form of investment ventures, or maybe they want to become entrepreneurs, because they are not satisfied with 6%, they are not even satisfied with 8%, they are not satisfied even with 10% or even 11%. They say that our cost of capital is 15% and more, and that can come only from making investment in any business. So in that investment you are taking risk also, so you deserve the higher rate of return also, and you can easily evaluate that if I make investment in any venture, maybe not one time, it is a periodical over a period of 30 years, for example, in this case, and if this is the return you are going to work out, so how much it is going to grow at what level, you can easily find out. So it's a very important application of the time value of money, and this is going to help us to take very, very important decisions. Next thing is, the next application of the time value of money is how much should you save annually. Means you want to achieve any objective, economic objective in the life. So how much you should save annually for achieving that objective. Now in this case, we are assuming our objective is of buying a house. We want to buy a house. Or for example, you just joined an engineering college, first year of the BTech, right? And you have 4 years to go, and after 4 years, or maybe after working in the industry for 1 or 2 years, you want to set up your own venture, your own project. You want to set up your own venture. So you can easily get the answer of your question, how much should I save annually from all my sources, so that I can get the required sum of money which I can invest into my proposed business, and I can become an entrepreneur. So it can be any purpose. It can be a purpose of buying a house, which we are taking here. It can be maybe buying a car. It can be buying any other asset, or it can be of setting up of a business. If you want to set up a business yourself, and you know that how much minimum sum of investment would be required, so in that investment sum, in that sum of investment required, you can easily find out how much you have to save annually, so that at the end of the given period, you can reach up to that amount. So for example, the question here is, you want to buy a house after 5 years, when it is expected to cost you 2 million rupees. 2 millions means 20 lakh rupees. How much should you save annually if your savings earn a compound rate of return of the 12%? So what is the target? How much investment you want to make? After 5 years, you want to make investment of 20 lakhs or 2 million. And you see that any investment avenue you have is, that's going to give you 12% rate of return. So how much should you save annually? Is there any application of time value of money which is going to tell us in a direct possible manner that how much should I save annually to have that much sum at the end of the 5 years or 6 years or 10 years, so that I can easily invest that money into my venture, into my business, and I can grow with that, and I can become an entrepreneur. So in this case, we have to use the future value interest factor for a period of 5 years of annuity, because we want to find out a same sum outflow of the same sum. Save annually means in the form of an annuity for a period of 5 years. How much should I save for a period of 5 years? It means that should be the equal amount, equal sum. And when it is the equal sum, that is called as an annuity. So we will have to calculate, to answer this question, how much should I save, or should you save annually? To answer this question, we will have to use the future value interest factor for a 5 years of annuity given the interest rate of 12%. Because you have to find out this value, which is ultimately the answer. You have to find out this value, and this is going to be the annuity figure, annuity value, because every year you have to save this amount, 3,14,812. So it means, being an annuity sum, you can use this model of the model is the future value interest factor for A means annuity. So when you look for the present value interest factor tables and future value interest factor tables, so in the present value interest factor table also, you will find out the present value of maybe you call it as a simple PVIF interest factors, present value interest factor tables, and you can find out the present value interest factor for the annuity also. So it can be annuity sum, it can be non-annuity sum, it can be uneven series also, it can be annuity also, so it can be uneven cash flow. So you have to refer to the PVIF table. But if it is annuity sum, then you have to calculate, you have to look for the factor, you have to look for the table, that is the FBIFA. This is the future value, but in that case, we have to look for the future value interest factor table. So it means, when you want to go for the present value, you can calculate the present value PVIF for the single sum or single cash flow, or for the annuity, or maybe uneven cash flows or the annuity. Similarly, the future value you want to calculate, that also you can find out for the single cash flow or uneven cash flow, as well as for the annuity also. This is a case of annuity. So we will use this model of the future value interest factor for annuity. The number of years is 5 and the interest rate is 12%. And finally, annual savings which we have to make it, with the help of this, if you expand this, you can easily find out this is the R is the 12%. So it is going to be 1 plus 12% power 5 minus 1 divided by 12%. So this is going to be the factor, with us. And if you divide this, the money you want after this period of 5 years, if you divide this 20 lakhs by 6.35 53. So you will get this sum, that every year you want to. So means every year you have to save 3,14,812. So you have to use this future value interest factor for annuity, not the future value interest factor only, because every year the sum of the savings is going to be same, and that's called as the annuity value. And if you save 3,14,812 each year, then after the end of 5 years, at the rate of 12%, for example, if it grows at the rate of 12%, this sum is going to be 3,14,812 is going to be 2 million or 20 lakh rupees if it grows at the rate of 12%. So you can look for the present value interest factor tables if you want to calculate the present value, but of the uneven series. And if you want to calculate the present value of an annuity, so you have to look, the table is the PVIFA. In this case, we are talking about the future value. So you can calculate the future value of a uneven say outflow also or series also. Table to be used would be future value interest factor, and if you say that the sum is going to be annuity, so in that case you have to use the future value interest factor for annuity table, and you will easily find out against 12% and against 5 years. R is 12%, N is 5 years. So the sum which you are going to save is, that is 3,14,812. So if you save every year and invest it in an avenue which earns the return of the 12% after a period of 5 years, this is going to grow up to 2 million rupees or 20 lakh rupees. So this is the second application of the time value of money. Similarly, there are the number of other applications of the time value of money also, which are going to answer many critical questions for you with regard to making investment into any avenue including business. So all those remaining applications of the time value of money we will discuss in the next class. Till then, thank you very much.